Hi, welcome to Peace in Math. In this video, we're going to talk about how to add, subtract, multiply, and divide complex numbers. First, a complex number is of the form a plus bi, like this for example. You have a real part and an imaginary part. The imaginary part comes from I being defined as the square root of -1, but don't worry about that right now, we'll get to that later. Let's start with how to add and subtract complex numbers. Here's an example of two complex numbers being added. Now adding them is really easy, you're basically just combining like terms. So if I combine the real numbers, the 4 and the 5, those add up to 9. And if I combine the imaginary parts, this 8i and -9i, those would add up to -1i. Which I'm just going to write this as 9 minus I. So adding complex numbers is really easy. Subtracting complex numbers is pretty easy too. You might find it easier to distribute this negative before you combine your like terms. So distributing the negative, I'm going to bring down the first part, -2 plus 7i. This becomes -3, and then negative times negative becomes positive 11i. And then now I can combine my like terms just like when I'm adding the complex numbers. So the real numbers, -2 and -3, these add up to -5. And if I combine the imaginary parts, 7i and 11i, those add up to 18i. So then my final answer is -5 plus 18i. Here's an example of multiplying complex numbers. Since nothing's in between these parentheses, it's implied we're doing multiplication. So we're going to simplify this expression using the distributive property, or you might also know it as FOIL. So I'm going to distribute 2 times 5, that would give me 10, and then 2 times -4i gives me -8i. And then I'm going to distribute this 3i to both terms. So 3i times 5 gives me 15i, and 3i times -4i gives me -12i squared. Now here's where that part about I being defined as the square root of -1 that we talked about earlier is going to come into play. So if I is the square root of -1, that means if I were to square this, square and square root cancel out, and that would just leave me with -1. So from now on, if we see I squared, we're going to replace that with -1. So right here, instead of I squared, I'm going to bring down the first part, 10 minus 8i plus 15i, and then -12 times, and instead of I squared, I'm going to put in that -1 right here. So this part is going to simplify to just +12, and I can bring the rest of it down. Now this is always going to end up being replaced by -1 for the I squared, so you can start to take some shortcuts. Instead, in the future, when you see -12 times I squared, it's just going to end up changing the sign to +12, so just cross this off and write +12 right after it. Then you won't have to write any of this stuff out, because that's too much to write that out. So now if I continue combining my like terms for my final answer, we've got +10 here, +12, so those add up to 22. And if I take the complex part, the imaginary numbers, -8i and 15i, those add up to 7i. So my final answer is 22 plus 7i. The main thing with this you have to remember is just if you see I squared when you're multiplying, replace that with -1, which will just change the sign. Then you can combine all your like terms. Alright, now for the main event, dividing complex numbers. So I need to get this into the form a plus bi. So in order to do that, I'm going to have to get rid of this denominator in the fraction. So how we're going to do that is we're going to multiply top and bottom by the complex conjugate of this denominator. Now, what the heck is a complex conjugate? Here's some examples of some random complex numbers. The conjugate of the first one would be 7 minus 8i, the second one would be 5 plus 2i, and the last one would be -3 minus 9i. Notice you keep the real part the same, you only change the sign of the imaginary part. So that's how you find the complex conjugate of a number. So now going back to this example, I'm going to multiply top and bottom by the complex conjugate of the denominator. So on the bottom, I have 3 plus 4i. The complex conjugate would be 3 minus 4i. And I'm going to multiply top and bottom by this 3 minus 4i. So I'm going to put some multiplication signs here, and then I'm just going to put parentheses around everything since I'm doing multiplication. So I'm going to multiply everything that we have on the bottom, and then I'm going to multiply everything that we have on the top. So on the bottom, if I multiply this out, just like we did in the multiplication example, I'm going to distribute 3 to both of those terms. So 3 times 3 gives me 9, and then 3 times -4i gives me -12i. And then I'm going to distribute 4i to both of the terms. 4i times 3 gives me +12i, and then 4i times -4i gives me -16i squared. And then since we have the I squared, again, remember we place that with -1. So instead of it being -16i squared, this is going to become +16. And now we use the complex conjugate because now if I simplify what we have on bottom, this I squared is gone, so now I just have a real number. And these numbers in the middle, these terms, -12i and +12i, those add up to 0, so those are gone. So now in the denominator, I just have 9 plus 16, which if I simplify is going to give me 25 on the bottom. And that's going to be a lot easier to work with to get it into this form a plus bi. Now let's multiply out the top. I'm going to cover up this bottom just to make it a little bit easier so it's less distracting. If I multiply, we're going to do distribute again. 1 to both of these terms. So 1 times 3 gives me 3. And then 1 times negative 4i gives me minus 4i. And if I distribute, negative 3i times 3 and negative 3i times negative 4i. Negative 3i times 3 gives me negative 9i. And then negative 3i times negative 4i gives me positive 12i squared. And once again, we have I squared. We're going to replace that with negative 1. So instead of it being plus 12i squared, this becomes minus 12. And now let's combine our like terms. We've got the real numbers, 3 and negative 12. These will add up to negative 9. And if I add up the imaginary parts, negative 4i and negative 9i, those add up to negative 13i. So now looking at the whole entire thing, I'm going to just rewrite this over here since I'm running out of room. I just need to write this in the form a plus bi. So what we're going to do is we're going to divide both the terms by that 25 on the bottom. So we have negative 9 divided by 25. That we can't really simplify, so we're just going to leave it as negative 9/25. And then same thing with the bottom. 13 can't be divided by 25, so I'm just going to leave it as 13 over 25, and I'm going to write the I after that at the end. So now this is in my form a plus bi, and we can't simplify this any further because neither of these fractions can be reduced. And that's dividing complex numbers. Feeling like you need some extra practice? Take a second, pause the video, and then try these ones out on a scrap piece of paper. At the end, you can check your answers to see if you get the right solution. Good luck! Here's a list of all the answers to the extra practice examples. I hope this helps you to get a little more comfortable with these types of problems so they're not so complex. Sorry, couldn't help it. See you next time.